And now we're moving on to the last session for today. Now I'll just share my screen. Okay, this is the last session for today, and we're going to talk about open innovation. I'm Glenda Caldwell, and in this session we'll hear from Professor Greg Hearn, Diego Camilo Herrera, who's a PhD candidate with us, and Associate Professor Corey Stewart, who's the ArmHub CEO. So one part of our research with UAP through the IMCRC Design Robotics project has been to explore open innovation and how we can create a network to share the research outcomes and the knowledge that's being generated from our work. So one of the key things that we've been doing is looking at the commercial projects that UAP uses to integrate advanced manufacturing technologies. So each year we've been looking at a design project, an architectural project, and an artist project. And we've been documenting how these technologies are implemented in UAP's different workflows. So this is an example of one of the commercial works that UAP did. It's called the 80 Collins Street facade. And basically the design was a complicated woven balustrade element for this building in Melbourne. And in order to design and document this, this sort of woven structure is really quite complicated. So UAP used virtual reality with some sculpting software to literally sculpt and generate the design in this 3D environment. Once they had that 3D model, they then sent it to the robot to do robotic pattern milling, and then they use that in a last foam casting process. So we documented this, and we use open innovation, the funnel that's generated by Chesbrough and Bogers, to look at how the different sources of knowledge come into UAP's workflow. So open innovation is about bringing in different sources of knowledge into an organization, in between organizations, or at an ecosystem level. So you'll hear from different ArmHub researchers where we can look at how that's happening at an ecosystem level. But here with UAP, we can see how the design is coming in from the architect. The design concept is generated with UAP. They brought in knowledge from VR software to generate that 3D model. And then they're using hot wire cutting and adapting that to a large industrial robotic process to then generate the pattern. And then they used a lost foam casting to generate this here panel. So this process really sped up the finishing at the end, and also the complicated pattern making that would actually be very difficult for a human to do. And on the other side, the external research support that we've provided through Design Robotics is also mapped out in this funnel. And through the Design Robotics Open Innovation Network, we've been writing reports and we write papers. We have events and presentations such as this, where we can share the different research outcomes with others, such as yourselves. So now I'm going to pass it on to Professor Greg Hearn, who's going to talk more about open innovation.
Hi, folks. We've heard a lot about design and robotics. Very important. The question that we're addressing in this session is, how do we get this out to companies and organisations, public sector, private sector, through a process of open innovation? We're very lucky to have the support of the Innovative Manufacturing CRC in Design Robotics project, and also working with us in the ArmHub, which I think is the first secret, is to don't stay in the university but go out into industry, and the ArmHub is an industry-based facility. And since we opened our doors in January, and our CEO Corey Stewart will talk more about this, we've had companies walking in off the street, and we're trying to figure out the best way to take the knowledge that we're creating and get it quickly and effectively out to industry through an open innovation framework. So as Glenda said, open innovation essentially is about doing innovation outside of the boundaries of the organisation of the company or the organisation that you're working with. There are many different models of open innovation, and we're learning what the practicalities of making that work are. And we've learned some things about the misperceptions that people have about open innovation. So it's important to say what open innovation is not. It's not only about open source, it can be built on open source, but it's not independent of contracts, licenses, and IP. We have to deal with all those things. It's not limited to companies of any particular size. It's not effective in every company. And it's not independent of the competition for ideas, which we find with SMEs and companies of all sizes. We're learning about the pros and cons of open innovation as we try and make this work in the ARM Hub and in projects like Design Robotics. So what we're finding is that through open innovation, companies and organizations can certainly get faster access to the cutting edge of technology for exploration or for actual access. They can share the cost and risks of embarking on an innovative process and a technology transfer. One of the big findings we're discovering is the benefit for companies in terms of just training and exposure of their workers, and particularly with UAP, who has a very strong manufacturing workforce based on the manufacturing floor. Their upskilling and their knowledge of new technologies like AR and VR and robotics has been pretty remarkable. Supply chain partnering is another pro. We're finding companies who are at different levels of scale who want to collaborate with larger companies. And also, of course, there's access to public funding. IMCRC Design Robotics is just one example, but the ARM Hub is partnering with all sorts of companies to speed the access to public funding. We need to talk about the cons as well. So for a lot of companies, they fear that it might delete their control. They find sometimes the IP management is complex. And the other thing is there's an argument that companies sometimes need to build their own capacities in technologies inside the organization so that they actually know how to adapt to the very latest technology. Of course, there could be leakage of knowledge. And the other thing that the research says as well is that just because a company gets a technology doesn't necessarily mean that that can build their innovation from that. So the challenge, I think, for us, and Corey is going to talk more about this, but some recent research on SMEs in Italy said this: despite the increased interests of practitioners, we know surprisingly little about the micro foundations. So on a day-to-day basis with individuals and companies in the hurly-burly of business contracts, how do we actually get open innovation to work? I'm going to hand over now to one of our PhD students who's working here in the ARM Hub and is an example of the kind of practical work that we're doing here. So handing over to Diego now.
Hello, I am Diego, and I am a PhD student. I am conducting a research in the ARM Hub. So, okay, my research, after doing the literature review, we just found some challenge that companies has to meet in order to survive. So in my research, we'll see how also we found 3 domains in order to help the companies to see how they can meet this challenge. But what if it's possible to find or to create a new domain based in these 3 domains in order to see if just with one domain we can meet all these 3 challenges. Okay, the challenge that we found, the domains that we found are green manufacturing, which will help companies to meet the challenge about sustainability, to decrease environmental impacts. And also the other domain that we found is digital transformation. This domain will help companies to meet the 4.0 industry challenge in order to transform conventional process into innovative technologies, and also working under an open innovation scheme that will be a help to the companies to share knowledge, outputs, and inflows of knowledge. As I said, we are trying to see how can combine, how can integrate these three domains in order to create a new one. What we are trying to do in my research is to get all the basic principles of those three domains in order to see how they can be combined to help companies to meet the challenge. So to clarify or to have a better understanding of what we are doing, let's see this graphic. If a company is trying to integrate the green manufacturing principle into its production process, this company will be doing a research in how to reduce environmental impacts. If companies are working under open innovation principles, these companies are sharing inflows or outflows of knowledge. If we can find companies that are sharing inflows and outflows of knowledge to reduce environmental impacts, obviously these companies are meeting open innovation principles and also green manufacturing principles. If we got the third domain, which is digital transformation, we can see that a company which is researching in how to replace conventional process by innovative technologies, it's possible to see that this company is integrating the digital transformation domain into its production system. If we find companies that are sharing inflows and outflows of knowledge where conventional processes are replaced by innovative technologies, it's possible to see that these companies are working under open innovation principles in order to integrate the digital transformation domain as well. And also, if a company is researching in how to replace conventional processes by innovating technologies with the aim to reduce environmental impacts, it's possible to see that this company is integrating digital transformation principles and also green manufacturing principles. The main output of my research is to try to find something where companies are integrating the three domains. Companies that are sharing inflows and outflows of knowledge in where conventional processes are replaced by innovating technologies with the aim to reduce environmental impacts will be integrating the three domains and also meeting all the challenge that the business is requiring. So the research that we are conducting in the Arm here try to find an answer for the following question. How can open innovation approach be used to foster green manufacturing and digital transformation principles in three small companies' production systems from the Arm here? Okay, I am going to pass the presentation to Corey. Thank you.
Hello everyone, what a great privilege it is to be here and be part of this group of discussions. My name's Corey Stewart, I'm the CEO of the Arm Hub. The Arm Hub really has emerged out of the successes of the Design Robotics project because so many companies are interested in how to use some of the technologies here and how they might apply to their own businesses. So for the last 3 years, as the Design Robotics project has been going on, we've been engaging a wider stream of companies in those activities and additional manufacturing activities. Companies ranging across sectors, so a fair bit in medical, for instance, defence, agriculture, green manufacturing like Diego was saying, so across the whole gamut. So what I'd like to just touch on today is what the Arm Hub is. We're a not-for-profit company. We exist really to uplift the whole digital capability of the manufacturing industry, like I said, across sectors. We're established by two founding companies, so that's QUT and UAP, our collaboration partner you've heard a bit about today, but we're largely funded from government. Queensland Government is a big investor, also the IMCRC, CSIRO, and other partners that are coming on board and doing projects. And you can see here through this image that Greg has showed previously, we're engaging with a significant range of companies, also significant range of university sectors across the country and indeed internationally. A lot of robotics providers and integrators. We work to amplify the capability of a lot of technical companies too. So sometimes they're our main partner and we deliver into other industry sectors in collaboration, or we increase their ability to work with other industries. So, and we work across a whole range of government bodies and industry bodies as well. What we're really here to talk about today is what's so unique about the Hub's open innovation model. And there is many things that we need to talk about so that people understand exactly what we're here to do with this wide-scale industry uplift and what it requires of us to do it well. And we do know from practices mostly internationally, because there's not a lot of this activity happening in Australia at this time, as an independent company, we really need to show the values that people are looking for to be able to collaborate. And Greg did touch on some of these as well, but mostly it is to be transparent, to be neutral, to really identify our values about where we stand and how we make decisions, and to be very open and flexible. Flexible is a really important part of this. One of the drivers about the Hub coming out is really about bringing a lot of the technical capability that sits in research institutions and collaborating with technology companies to service other companies. So it's a kind of complex collaboration arrangement, but we need the tools. So we have a very broad range of contracting tools that is about making this happen in the most equitable, the quickest, and the most collaborative way where everybody gets the outcomes that they need. And so one of those areas is about being really certain about something, so collaboration is easy. People understand exactly what they're walking into, and that is around IP. So the Hub has an IP model where if industry is investing in it, of course, it's their IP, it's what they need to retain to uniquely deliver their capability into the economy. Sometimes, and in fact about half of the time, we're engaging with companies that are looking for manufacturing improvement, where that IP is not something that they're looking to commercialise, and indeed it may not be worth any intrinsic sort of value. So the Hub seeks to carry that IP as a commercial licence to make it available to other companies, so we do not have to sort of create base IP from the ground up. So this is one of the really important principles about a wide-scale industry uplift, and also accessing significant levels of government investment from state and federal grants, etc. So we set up this model and we talk about it with each of the clients that come through, and of course it determines the kind of cost and structure of their projects that they run with us. We've found that about a third of the companies are deep tech companies that we're working with in a way that really command the use of their IP as their unique proprietary capability. We're finding another third of companies are really kind of strong tech companies that may or may not want access to that IP in a unique fashion. And then we're finding the others are really companies in the kind of front end of industry sectors, whether it's shipping, like I said, agriculture or medical, where they really just want to be able to use that technology. So that's the kind of breadth of kind of technical overview of the companies we're working with. But again, we also work with very large companies and right down to very small micro enterprises. Our real sweet spot is the SME company. So we are doing some very interesting things to bring opportunities to SMEs and micro enterprises. We're first of all working with them to collaborate onto bigger projects. We're trying to run projects as sprints, so we offer just a commercial sprint engagement so that they can really understand what their next technical challenge is and how applicable it is to their businesses. We're also collecting lots of SMEs together when they have a shared challenge or a supply chain challenge even, and seeing how that collaboration can wield greater, I guess, momentum for taking the whole sector forward through innovation projects. So this has been, we've been in existence now for 5 months. We are working with over 100 companies, some very deeply, some as touch points and advice. We have this fantastic facility, which really was just a, empty shed. And I'm just going to have a very quick scoop around so you can see some of those you've been talking to today. But over there, you can see the makerspace down there. Hello, everybody. and my colleagues that have just been speaking to. So I'm very proud of the Arm Hub. I'm very proud of a very hard-working core team that make this all possible. And we also have in our shed, which you will have seen a little bit then, we call it the Learning Factory, in fact. We have a number of companies that co-locate with us, mostly so they get access to the expertise as well as the space, and increasingly shared services like financials and even engineering support. We've got companies ranging from mining companies, space companies, construction companies, and just tech companies around water filtration at this point in time. We've already really reached our limit of, and we'll be looking for new facilities to expand into very soon. So I welcome any questions about the Arm Hub. We are in Northgate in Brisbane, so not far from the airport. So it's also a space where you can come and work with teams if you've got something to collaborate on, or you can come and visit. So the Arm Hub isn't really just an independent, isolated facility. However, we have this great network across a range of university partners. In particular, I suppose QUT is a founding partner, but we're very quickly, as you've seen today, collaborating with RMIT and other opportunities, Griffith University, UTS, and working the Sunshine Coast University, which is nearby, and we'll work our way across the country. We work closely with CSIRO and their robotics capability nearby in Brisbane, in Pullenvale, but also in Melbourne down at Lab 22. So this is actually an expanding exercise. In the 5 months it's grown this far. We have a very important partnership to us with the Fraunhofer in Germany, who are really the experts at building a network of advanced manufacturing capability. They are definitely leaders in their field, and they're a partner too with their robotics team and their digital and data science teams. So this is a good example. I'm sure this image will look a little bit too busy within a few months to put up in this sort of fashion. So that's a little bit about the Arm Hub. I think I'll hand over now to Glenda, and she'll close up the session with Joe.
So thank you, everyone. That was excellent. We have some time now that we can take some questions from the audience. So I hope you enjoyed all the exciting research that we've shared with you today. And please do send through some questions, because the team is here and ready to answer.
That's definitely right, Glenda. I mean, one of the things I would say while you're thinking of your questions is that I hope it's clear from the presentation that we've given today that we're really trying to live this philosophy of being open and sharing what we do and inviting people in for collaboration. So first things first, if you want to collaborate with us, we are very open to that, both through the Arm Hub, which Corey has just talked about, and also you can contact us through the designrobotics.net webpage. Just go there and find out about the research we've been doing, and feel free to reach out to any of us. We're really keen to help transform Australian manufacturing. While we're waiting for questions, I might actually throw one to the panel myself, if that's not too cheeky, because I was really, I love hearing what everyone else is saying. So here's a cheeky little question for Peter Cork. Peter, if you could solve one fundamental problem in robotics technology for manufacturing, one fundamental problem, what would that be, and why?
I think a problem interests me a lot is how can we do the sort of force control motion that that we see the skilled people at UAP doing. I think that's a really important skill for a robot to be able to emulate, because we know that the work is backbreaking, is done in harsh conditions. So I think that's an important one to solve.
I mean, from a human-centered sort of view as well, it's actually fascinating to think about how could a robot do some of these human tasks. Often they start out by seeming quite mundane, but when you find out about the amazing skill that's involved in it, you find out there's a lot more to the task. And maybe I'll ask a follow-up question to that to Corey. I'm dropping bombshells all over the place. But Corey, my question to you would be, is manufacturing dull, dirty and dangerous, or is it becoming a more creative kind of a profession? Where do you see the future of manufacturing going from a creativity and design perspective?
So we are definitely seeing across the industry sectors that manufacturing is becoming more creative in the sense that it's becoming more personalised. So personalised products, people looking to manufacture unique things or short runs of things, and also more iterative processes. So we're starting with one sort of object and moving quite quickly to generation, prototype 1, 2, 3, 4, and it can change quite rapidly. We are also seeing, and that's from kind of a medical sense where things tend to be smaller, right through to making new objects for construction and a kind of construction scale, like a building scale. So that opportunity is really also the opportunity we have as a country to really provide highly value-added products into the market using our capability, like the team here on this session, because we can use these high-value skills to create new and novel things that have a greater value. So that's really what we're seeing a lot of. However, there is also a very wide-scaled industry sector, say from Golden Circle just down the road, right through to recycling industrial waste, that does have very much a dirty and dull and dangerous part to it. And we are seeing a need to resolve those challenges too. And that usually is something that engages quite closely with the workforce. So in mining applications too, most of it has a safety element to it as well. So sometimes they're tied quite closely together in terms of innovating, improving safety, but also improving the novel and new dimensions to what's being produced.
Right. Thank you so much, Corey. I can see in the Q&A there is a question there from Praveen S. And I think that's a question probably for Mike or Roland. And the question is, have these evolved designs with Amoeba software been compared to existing natural and or man-made designs? And if so, with what sort of metrics? That's a fascinating question. Yeah.
I can answer that. Actually, we have seen a lot of our results compared very well with natural occurring trees or bones. I showed one example of apple, but the metrics we are using are structure performance, like stiffness, stress, and even though we are using mechanical rules, but the outcome, it occurs again and again to the same shapes we're seeing quite often in nature, like the trees and bones.
Great, and you can see that qualitatively when you look at it, but also through structural analysis.
Yes.
Is that right, Mike?
Yeah. Yes.
Great. Yeah, I mean, I've always been so interested in your work with the structural analysis, and I guess what would be interesting to me now is to ask about. I can see everyone, I'm looking down there because everyone down there is scrambling around their computer saying, is he going to ask me a question next? So yeah, I was going to ask Mia and, and Alex actually, could I ask you to talk about what it's been like to collaborate between the sites of Brisbane and RMIT and to sort of try to apply some of these novel fabrication techniques. What's that been like on a practical level?
Thanks for the question, Jared. No, it's been actually really good. I can't speak for Alex, but for me, it's been like a little bit painful just because, setting up something that Alex, he's just looking through on my laptop camera. It's been a little bit difficult in that sense. He can't really see everything, and because of course he was the first one who actually wrote the first parts of the code. And of course he implemented it in a way for his physical setup, but we didn't have the exact same stuff here. So we kind of had to haphazardly kind of merge it all together. But in the end, it ended up working out pretty well. We ended up being able to adapt all of that sort of stuff and work through it together. So we're very thankful for things like Zoom, just because it was able for him to, he could control my screen remotely, which was really useful. But at the same time, we set it up properly that we had 2 cameras going at the same time, and then we could actually talk through everything. So it was definitely a different experience to what we're used to, or what I'm used to rather. But I think it's been very positive in the long run. Yeah. Did Alex have anything to add to that?
Thanks for the question, Jared. I think it's a very relevant one these days as well, because I think that this was now a pilot project that we didn't plan like this. It just happened or something. And I'm just, yes, so of course it was a bit more challenging in not being at the same physical space, or, you know, we're from different domains. We don't share this exact same language. These are some kind of challenges sometimes to overcome. Apart from that, everything we've done, we used existing tools, right? So we can use Zoom. We have all this infrastructure built. I think from now on, moving forwards, I don't see any excuse not to do it in the future like this, because robots exist all around the globe. We all have computers. I could drive it from my phone in the bus, you know, I think we've built collectively as a society all these tools and infrastructure that we actually need to do remote collaboration or maintenance or something, fine-tuning. In this case, as a design process that needs a lot of interaction, it can be challenging, but it also can be done because we rely on all these great tools that we have available today. And I'm looking forward to what will change in the future, maybe using some kind of AR system so that it's even more immersive and we're not looking at the screen only. It's been a great experience, and I'm looking forward to move on.
There's actually a question in the Q&A that's just come up from Andrew Laycock, which is, how are mixed reality headsets like HoloLens 2 being used for remote design collaboration, which I think follows on very nicely from that. And I think certainly Roland would be able to tell us about some of the use of HoloLens 2, and probably Glenda as well, from studies done at UAP. Maybe Roland, do you want to kick off on that?
Yeah, sure. I mean, we've used it not so much for remote collaboration, but certainly we've been using them on building sites. So one of the projects I showed, the 6 meter high 3D printed installation at the NGV, there weren't any assembly drawings or in fact, there wasn't a single drawing for that project. All the panels were directly 3D printed, and then on site, we used the HoloLens to assemble the project. So basically, we had a series of HoloLenses. So for those of you who haven't used or seen a HoloLens, it's a augmented reality headset, so you can see through and you can see, you know, what's in front of you, but then you can also see the digital overlay. And so that enabled us to have a digital 3D model of the design, and where every part was labeled. And that enabled us to be able to pick up a part, see where it goes, and then basically go put it in place and bolt it together. And so the thing that I found most remarkable about using mixed reality was that how easily it was adopted by people on site. So at the NGV, we gave it to a team of art installation experts who'd never used it before, and we've also used it on a building site. We gave it to a series of carpenters who had to build something, and I was a bit hesitant to give carpenters a HoloLens. I thought they would sort of like be resistant to technology, but as soon as they put it on, they were immediately not even talking about technology. They didn't say, "Well, it's amazing, I can see what I have to build." They just started pointing at bits of it and saying, "Hang on, how are you going to build that? Or what do you do with that conflict?" Like, they immediately just adopted it as almost as it was a sort of native technology to them. So that was for me, that was remarkable. Obviously, it saves a huge amount of time in terms of not having to develop working drawings, and when you're trying to assemble something that's complex, it's so much easier to see the 3D model than try to refer back to a two-dimensional representation of it.
I think this also actually relates to an earlier question we had about Lindy Lee's panels, which were shown as part of the presentation, and whether technologies like VR headsets or things like the HoloLens might be used there as well. Perhaps, Glenda, you could talk to that, and we could also answer that previous question a little bit more too.
Yeah, thank you. Thanks, Shelley, for that question. So UAP has been very innovative in how they adapt and adopt different technologies, including VR and AR. So they've got some great examples of using VR for sculpting to develop the 3D model, which then they feed to the robot. So I mentioned that briefly. But they also use AR for the assembly of different complex structures. So in some instances, they'll overlay the digital model into the real sort of piece, and then they can map out where the drill holes or welded connections need to be. And what's great about that process is that it's really streamlined the documentation that's required, because some of these forms are very complex in their form, but also in the number of elements that need to come together, the materials that are being used, and just the range of tools that have to be used to assemble these projects that are very complicated but also really beautiful, and to get them precisely assembled on site. There's been great uptake in terms of using the augmented reality on site, but also within the workshop floor. So different workers within UAP, who may not have had much access or interest in using extended realities, have been adopting these into their everyday practices. And for us, it's been fantastic to watch that process happen, and we certainly are learning a lot from all of that.
Thank you, Glenda. Look, that's 11:30 now, so that's where we said we would end. There's just one question from Jacobo Camelo, which is asking about whether some of these techniques could be applied to things like printed electrical circuits. And actually, Jacobo, this is one of the most interesting things we've found from this ArmHub collaboration, is that we find really interesting connections between the world of art and design fabrication and things like medical technology, or maybe even, as you suggest, printing electrical circuits. So yes, I think there's definitely always opportunities for that kind of cross-pollination. Thank you everyone so much for your time today. I'm going to go to the bakery now and buy a cake for everyone to reward them for their amazing presentations. Thank you all.